Okay, welcome back to WSHS Algebra 1 Virtual Tutor. Today we're going to continue with slope, but this time you're going to learn how to graph it. Last time you learned what it looked like, right? So positive, negative, zero, or undefined slope. And this time you're going to learn how to actually graph it, okay? So we're going to graph linear equations, and we're going to graph inequalities as well. So equations and inequalities with two variables, meaning when you have an x and a y in your equations. Okay? All right, so graphing linear equations in two variables. To graph linear equations, we must first make sure that the equation is written in slope-intercept form. Remember, we talked about this last time, where the equation has to be written in the form y equals mx plus b. Because when it's written this way, the m, which is the slope, tells you where to move, and the b, which is the y-intercept, tells you where to begin. Okay, so b for begin, m for move. And we're going to follow that a lot more today. Okay, so there are several different ways to graph a line. Okay, we're going to learn how to do it in slope-intercept form by hand, and then at the end of this lesson, there's some steps and some tricks on how to also do this on the graphing calculator. But if you don't have a graphing calculator at home, you're going to need to know how to do this by hand anyway, right? So using y equals mx plus b, remember to first put the equations in y form, meaning slope-intercept form. They have to be in this form first before you can graph. Okay, so for example, we look at example 1. It says negative 2x plus 5y equals 15. Well, this is not in slope-intercept form because slope-intercept form means the y is by itself. Okay, so what I want to do is rearrange this, and we worked on that last lesson. 2x plus 5y equals 15. So I want y by itself, and in order to do that, I'm going to have to move this negative 2x over to this side, right? So what I want to do is the opposite of a negative 2x to move it over, which is a positive 2x or plus 2x. Okay, so that leaves me with 5y equals, and remember the mx part comes first, so the x variable comes in the front, and then the 15 comes afterwards. So 2x plus 15, and it's plus 15 because that's a positive number, right? Okay, y is almost by itself. We got one more step. So we're going to divide by the number in front of y, and we have to do that to everything. Okay, so that would leave me with y equals, if you do 2 divided by 5 in your calculator, you're going to get 0.4, okay? But remember, we need to leave it back as a fraction, so you have to hit the math, frac, enter, math, enter, enter, and it'll still give you 2 over 5 here. So remember, the slope, the number in front of x is the slope, and it's always in a fraction form. The slope is rise over run. Okay, so you have to leave in fraction form. The only time you don't see it like this is if it's a whole number. So if we had something like 2x, then 2 is my slope, right? So my rise is 2. But my run, if there's no number at the run, technically any whole number can be written as a fraction by putting it over 1. So really my rise is 2, my run is 1. So just make sure slope, you can't leave it as a decimal. Can't be a decimal. It can be a whole number, it can be a fraction, but it cannot be a decimal. Okay, so make sure you keep it in fraction form. All right, so 2 over 5x plus, and then 15 divided by 5 over here. We're back here, right? 15 divided by 5 is 3. So this is your new equation in slope-intercept form. Once we have in slope-intercept form, then we can actually go ahead and graph this, right? So the number in front of x is the slope. We said this is the m. So m stands for move, and this would be the b, and this stands for begin, right? Y equals mx plus b. So move 2 over 5 and then begin at 3. Remember, we begin on the y-axis, okay? So my y-axis is this one here. So that's where we begin. Okay, so the 3 is positive. The 3 is here. So I'm going to begin at the 3 on the y-axis. I'm going to plot a point right there. Okay, and then looking at my equation, it's telling me to move according to this fraction. Okay, so we are going to, if the slope is 2/5, that means slope is rise over run. So we're going to move 2, and if 2 is positive, that means we're going up, right? We're rising up, and then we're going over, we're running to the right, 5 spaces. 1, 2, 3, 4, 5. Okay, once we land at our destination point, we're going to plot a new point right there. I'll make it darker. Okay, so we want to do this again. We want to do it at least 2 times, so you have 3 whole points. You have the first point that you began, right, the y-intercept, and then we move according to our slope, our rise and our run, and we want to do it a second time, so we have at least 3 points on our graph here, okay? So again, from this new point that's black here, we're going to move up again, 1, 2, that was our rise, and our run is 3. I'm sorry, 5. 1, 2, 3, 4, 5. And wherever you land, you want to place a point. Okay, so once you have all 3 points, what you want to do, let me get a line here. What you want to do is connect your dots. Okay, you're going to connect them with a ruler or some sort of straight edge. And let me fix this. You want to make sure that you're going through those lines. Those points. Okay, and that you're making it, you got to go all the way across the grid, from one end of the grid to the other end of the grid, because that line technically continues on forever. Please don't stop your line right there. Okay, the line does not end. Line technically continues on forever, so you want to make sure you cross the entire grid at least. Okay, and that's how you would graph. All right, so here's your tip here. This is what I was talking about. Standing at your beginning point, you're going to use your rise and your run values to plot your second point, and then do it again to plot your third point. This right here says if your rise, so if the number on the top was positive, you're moving up. If the number was negative, you're moving down. If your run is positive, move right. If negative, move left. So remember, rise over run. If rise is positive, we're going to go up. Negative, we go down, however many spaces, right? Run, if it's positive, we go right. If it's negative, we go left. Okay, so let's try one. Let's try again. I want you to go ahead and try this one. Okay, if you need to pause the video to try it so that you can, or even if you need to go back and rewind to see the previous example again, you can do that. Otherwise, go ahead and pause the video now so that you can go ahead and try it on your own and see if you can do this. Okay, remember the first thing you have to do is make sure that your graph is in your equation is in slope-intercept form, so y equals mx plus b. You begin at the b on the y-axis, and then you move according to the m. Okay, rise over run. If rise is positive, you're going up. If it's negative, you're going down. If run is positive, you run to the right. If run is negative, you go to the left. Okay, I'm gonna pause the video myself here. When you're done with the you try, then go ahead and unpause the video, and then you will see the answer to see if you did it right. Okay, so what you should have done was rearrange your equation, right? We need to get y by itself. So what you had to do was move this negative 3x over here to make it a positive 3x to both sides. So you would have gotten 4y equals 3x minus 8, because that was a negative 8, right? And then if you divide by 4 to everything, you would get y equals 3/4 x minus 2. Now 3 over 4, if you got 0.75, you have to change it back to a fraction, right? Because we need the slope is rise over run. And then negative 8 divided by 4 is negative 2. Okay, so if y equals mx plus b, this tells you where to begin, and this tells you how to move. Okay, so we are going to begin on the y-axis at negative 2. Okay, and we're going to move according to my slope here. So the rise is 3, and it was positive, right? So we're going to go up. And then the run is 4, and it was positive, so we're going to go to the right. Okay, so from my beginning point at negative 2 on the y, we're going to go up 3, 1, 2, 3, and over 4 to the right. 1, 2, 3, 4. Plot a point, do it again. Up 3, 1, 2, 3, over 4, 1, 2, 3, 4. Okay, once you have 3 points, you must connect your dots, and you want to make sure that you are covering the entire grid. So make sure you're extending that all the way. I have to fix this line a little bit so that I'm going through the points. Make it more accurate. Okay, I have arrows on each one of my ends already. If you don't, you want to make sure that you go ahead and draw your arrows. Okay, because that line does continue on forever. All right. The next thing we're going to do is graph linear inequalities. Okay, so an inequality is when we have this symbol right here, right? Less than, greater than, less than, equal to, or greater than or equal to. So you're going to graph it the same exact way as an equation, where you have to have it in slope-intercept form. The y has to be by itself. That way you can see where to begin and where to move. The only difference with inequalities is that we have to do something called shading when we're done. We also have to do something with the line. So we could either have a solid line, like a regular line, like remember when we did that, or sometimes we will have a dashed line. So you have to know the difference when to do what. Okay, so that's what these little clouds are here for your notes. Okay, you're going to have a solid line if you see these symbols with the solid line underneath them. Okay, so this is less than or equal to, greater than or equal to. So if you see that there's a line underneath your symbol, then you need to draw a solid line. If there is no line underneath your symbol, that's when you do the dash line. Okay, that's the first thing. Second thing, we're going to shade above when we see the symbol above for greater. Okay, so two symbols have the word greater in it. You have greater that looks like this, or you have greater than or equal to. We're going to shade below when we see less than. Okay, greater than, less than. So less than would be like this. or even less than or equal to. Okay, so above is for the greater than symbols, greater than or equal to. Below is for the less than symbols, less than or equal to. All right, so let's try example 2. So we're going to treat this just as if this were an equal sign, okay, where we have to solve for y to put in y equals mx plus b form. But what we should notice right away is looking at this symbol, am I going to have a solid line or dashed line? Am I going to have to shade above or below? Okay. Another thing to remember with this, and I'll fill it in down here, when dividing by a negative number, remember that typically when we do these y equals mx plus b and we're rearranging, a lot of the times our last step is to divide by whatever number is in front of the y. So in that case, if we're dividing by a negative number that's in front of the y, we're going to have to flip that symbol. We did that when we were solving the inequalities before. So the same thing happens here. Okay, so looking at our example right here, just looking at that symbol, is this going to be a solid or a dashed line? So remember, we said it's a solid line if we see that there's a line underneath the symbol, right? It's a dashed line if we don't see it. So looking at this example here, there is no line underneath there, right? Because there's no line underneath like this is going to be a dashed line. Okay, and where are we going to shade? So we said earlier that we are going to shade up if we see greater than or equal to. We're going to shade down if we see less than or equal to. Okay? All right, so looking at my equation or my inequality, sorry, again, this was our symbol, right? This is a less than symbol. So if we have less than, you can also think less and lower, right? L and L. We're going to shade below. So you have to make sure you remember that. All right, so let's go back here. We're going to go ahead and work this out. Okay, so we had 3x minus 5y. I'm just writing this bigger so I can go ahead and work this out and solve for y here. This is not in y equals mx plus b form, right? So we want to get the y by itself so that we could easily see where to move and where to begin. Okay? Because right now we can't say that we're going to move 3 and we're going to begin 5. That doesn't, you can't work that out like that, okay? So we need to solve for y. We need to get y by itself first. So I need to move this 3x over here because that symbol represents where my borderline is, right? So I'm going to go ahead and subtract 3x because that's the opposite. So now we've got negative 5y is less than, remember the variable with the x comes first, right? So negative 3x and then minus 4. Okay, last step is to divide. Now remember, we said when dividing by a negative number, we must flip the symbol. If you look, we have a negative 5 that we're dividing by. And we have to divide it to everything. So because we just divided by this negative 5, we must flip this symbol. Okay? All right. So if you did negative 3 divided by negative 5 in your calculator, you're going to get 0.6. Remember, you have to keep it as a fraction. So math frac enter, or math enter enter. That's going to give you a positive 3 over 5. Okay, and then negative 4 divided by negative 5 is going to give you 0.8, but you can't leave it like that, so you have to put it back to a fraction, which actually gives you a positive 4 over 5. And the reason why the signs changed were because negative divided by negative is positive, right? And they both had those double negatives there. All right, so this is my new inequality here. Now, from here, I know exactly where to begin and exactly where to move. Now, here, this begin here, unfortunately, this one was a fraction here for us. But this we said when we divided this, this was like 0.8. Remember that? So 0.8 is really close to 1. You know what? I don't like this because as far as graphing this, it's not going to be as accurate. We'll do this as accurate as possible. All right, so we're going to make this as close as possible to 1. And remember, we're beginning on the y-axis. So where is the number 1 on the y-axis? The number 1 is right here. We can't do it exactly at the 1 because this wasn't a whole number. This was a decimal. So we're going to estimate and do it right around here, okay? As close as possible. All right. So then we are going to move, okay? So we're going to move according to our slope, and our slope is always the number that's in front. So our slope was 3 over 5, so the 3 is our rise, and the 5 is our run. So we are going to go up 3. So you're going to estimate about 1, 2, 3, and over 5, right? 1, 2, 3, 4, 5. So you want to plot a point here. Okay, then you want to do it again. 1, oops, 1. Let me fix that. 1, 2, 3, and over 5. 1, 2, 3, 4, 5. Right around there. So remember, it wasn't quite a whole number, so I'm not going exactly on that line there. Okay, so now that we have the 3 points, we need to connect them with a line, right? But we've got to be careful with these because we said inequalities are special because we're either going to have a solid or dashed, and we said it was going to be dashed, and then we also have to shade, and we've got to shade below, okay? So the first thing we're going to do when we connect our lines, our dots, is we're going to connect them with a dashed line. Now I have this little tool that will automatically give me a dashed line, okay? But you will have to make the dashes on your own here. All right, so I'm going to connect. Oops, oh no. Let me try this again. Okay. All right, I'm going to connect. Remember, we said we want to go as far across the grid as possible. And that was not very good connecting. So I'm going to fix this here. Make sure you are hitting those points that you plotted, okay? The arrows go on each end here. Okay, so there's my dashed line. So I did the dash, and I also now want to shade below, right? We said below because this was less than. Now, actually, we got to be careful. This is no longer below. Remember what happened here? Because we did the division, and we divided by this negative, remember when we flipped our symbol? So we're actually not shading below, we're shading above. Okay? So we're going to shade above. So what do I mean by above? Above meaning greater, right? So where are all the y values greater than this line? Okay, so if we look, if I were to say this is my y-axis, right? And all of my y values, if I go up, aren't these numbers up here greater, right, than the ones down at the bottom? Yeah, so I'm going to shade up. I'm going to shade up here, meaning up, 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 up. All of this is up. So you're going to take your line and you're going to go up above the line, all the way across, okay? Up above the line. So that's how we would shade it. Okay, let's do another one. All right, so we're going to graph this one here. Okay, so before we can graph, we need it in y equals mx plus b form, so we know where to move and where to begin. Okay, so I need to get y by itself. So I'm going to have to move this -2 over here first. So I want to add 2 to both sides. Okay, so we're going to get -2y is greater than or equal to 3x plus 2. Y is still not alone, so I need to go ahead and divide by this -2, and I have to divide it to everything. So that's going to give me my y alone now. And I just divided by a negative, so remember I've got to flip my symbol, right? So positive 3 divided by -2 is still going to give me, if I did it in the calculator and wrote it back as a fraction, so it'll say -1.5, but you have to hit the math frac enter, and it'll say -3 over 2x. And then if you did positive 2 divided by -2, that's going to give you a -1. So now it tells you here, now that you have this inequality, you want to figure out where are you moving, where are you beginning, where are you shading? Do you have a solid line or do you have a dashed line? Okay, so this inequality right here is going to tell us a lot. This number here is where you begin. Remember, y equals mx plus b. This number here tells you where you move. Okay, so the rise was -3. The run was a +2. This symbol right here tells you two things. One, it tells you that you're going to have a solid line because of this symbol right here, because there was a line underneath. So when you connect your points, you're going to connect with a solid. And it also tells you where you're going to shade. Because this is less than, we're going to shade lower or below. Okay? All right, so let's start there. We're going to begin at the -1, and we always begin on the y-axis. So we're going to begin right here, -1 on the y. Okay, and then we're going to rise -3. So if you're rising -3, remember I said if it's negative, that means we're going down instead of up. So down 1, 2, 3, and then we're running to the right 2, because if it's positive, we go to the right. If it's negative, we go to the left. Well, my run was positive, right? So +2, 1, 2. Then we'll plot a point and do it again. Down 3, 1, 2, 3, over 2, 1, 2. You could even do it again if you want. Okay, so now that you have your points, again, you need at least 3 of them. I have 4 here, but you need at least 3. You're going to connect your dots. Now, we said that this was a solid line because it had the line underneath. So we're going to connect with a solid line. And you want to make sure you're going across the grid as much as possible, and you're going through those points that you just plotted. You've got to put your arrows on each end. Okay, and then the last part is the shading part. So the shading, where are you going to shade? Okay, so if I'm going to shade, we said we're going to shade below. Okay, now where is below? Well, below this line would be anything where the y values are starting to decrease, where they're starting to go less and less and less. And that's all the negative section here, right? Because as you go down here, these are all getting lower and lower and lower, right? So that's what below is here. And we have to make sure that when we shade, we're going across the entire line. We have to hit the whole line. So it'd actually be this whole section here. Okay? All right. Graphing in your calculator. If you have a graphing calculator, you're going to follow these steps to do the inequalities and the equations. Okay? So what you want to do is always make sure the equations are rearranged. Okay, you can't do anything without making sure they're in y equals mx plus b form. All right, when you have your equation, you're going to press y equals and put them into y1. You've got to hit zoom 6 to see the graph. Then you can go to your table and copy at least 3 points. Remember I said you need at least 3 before you can graph. All right, and then you connect the dots with a line. Make sure to put arrows on each end. So I'm going to go ahead and pull up my graphing calculator so that you can see me do one of them in here. One regular equation and one inequality. Let's see what we got. Oops. Okay. All right, so first let me clear everything out so that I can make sure, okay, everything looks good. All right, so if I had my equation, remember I can't do anything until it's rearranged, right? So let's say I rearranged my equation and I wound up with y equals negative 3x. Let me do a fraction to make it easier. Okay, to make it more common. All right, so let's say I get negative 3/4 as my slope. So 3/4 is a fraction, right? So there's a couple of things you can do. You could either do the second, I'm sorry, not second, alpha y equals, and that will give you the fraction. If you enter, that will give you the fraction format. So we can do negative 3/4 x plus 2. Let's say that was the equation I got. If you do the alpha y equals and you don't have that option, remember a fraction is the same as division, right? So I could even go in here, I'm going to delete this, and I'm going to put in the fraction. If you're putting it in as a fraction form using the division symbol, you want to make sure you put it in parentheses first, okay? So if it was negative 3/4, then I would open my parentheses, put negative 3 divided by 4, close parentheses, and then put my x. Okay, so that's negative 3/4 x plus 2. Okay, so that was step 2, right? So step 1, rearrange. Step 2, plug into y1. Step 3 says hit zoom 6. So I'm going to hit zoom number 6. Or you could also hit the graph button, right? It says or hit graph. And look, that's our line, draws very nicely. But you know what the points are, right? So you don't know what the points are really, not 100%, unless you look at your table values. So to get to the table, you guys have been working on this all year, you've got a second graph. Now, if you're plotting points, you want to find x and y values or x and y points that are not decimals, right? Because I said you can plot any 3 points. It doesn't matter. So plotting the ones that are not decimals are going to be much easier to put on your graph. So I can plot a point here at negative 4, 5. I can also plot a point here at 0, 2. I'm going to find another whole number. And you want to use your arrows up or down until you find 3 good points, okay? So I can plot another point at 4, negative 1. So I would just copy down on my graph paper, connect the dots, and that's how you do it in the graphing calculator. You want to make sure that on your paper it does look like that, okay? All right, for the inequalities, we're still going to put everything into y equals, but the difference is how do you know where to shade, okay? Now, the graphing calculator will not be able to do a solid line or a dashed line for you. You have to know how to do that by yourself. Okay, but what it will do is shade for you. Now, it will shade only if you put it in the right direction. So when you have, like, let's say this was y is less than or equal to or less than negative 3/4 x plus 2. I'll still put my equation in the calculator like this, but what I'm going to do is I'm going to arrow over to the left. So I'm going to arrow over as far back as I can see You see how this is blinking over here next to my y1 to the left of the y1? You see now it's blinking, right? And it's blinking because I arrowed over there. If I arrow to the right, it's going to move my cursor to the right. If I arrow to the left, I keep going until I see that blinking line. So once it starts blinking, you could actually go ahead and press enter, and you'll see the line change. So that's just going to make a thicker line for you. If you hit enter again, now you're going to start to see triangles. You see a triangle that's kind of facing up, right? If you hit enter again, you're going to see a triangle facing down. Okay, so if you keep hitting enter, it's just going to bring you around to other options. So you would go ahead and keep pressing enter until you see one of those triangles. The triangle up, that's going to shade if it's greater than. Okay, so if it's greater than, it's going to shade this line above. So I'm going to hit graph so I can show you what this looks like. So it'll show you exactly where to shade. Okay, I'm going to go back and I'm going to change the triangle. So if the symbol was less than or even less than or equal to, I want to keep hitting enter until I see this triangle below like this triangle down at the bottom. That's going to shade it in a different spot. That's going to shade it below. So if I hit graph here, now the shading is on the other side. So the calculator won't automatically do it for you correctly. You have to push it in the you have to press the right buttons in the calculator correct in order for it to graph it correctly. Okay? So the calculator isn't always right. It's the person pressing the buttons on the calculator that has to be right. Okay? All right. So all of these instructions are here for you. Okay? All of them are here for you. So if you want practice doing that, you want to make sure you're going through each of the steps, step by step by step. Okay? And that is how you graph linear equations and linear inequalities.